Okay, let's look at this switch statement here. It's just a switch, and based on the month, if it's the first month, we're going to call it the January function. Second month, we're going to call it February function, etc. Nothing wrong with this. This isn't complicated. This is 101 programming stuff, pretty much. But when I switch to it over here, it seems so much more pleasant. It seems like I instantly understand what's going on. For some reason, I got the switch, and then I had the case of 1, January, and break. It is a complete unit. It feels complete because of this pink stuff, this pink text. And same thing here and here and here. And this is just one example of many, but you can see here Visual Studio, PlatformIO, excuse me. The coloring is just really well thought out, where it to the point. I don't care about colors. I'm an engineer. I'm aesthetically challenged. I don't care about aesthetics, but I like being able to see and visualize and understand what I'm doing right away. And when I come back to Arduino, you could tell they started by, some of these library calls and analog and the functions. They have that orange color. That's nice, but a lot of times it's just. And is case and break colored? I can't even tell. Maybe they are colored different. Maybe I've got something wrong here. But just in general, Arduino is not taking the coloring of the code seriously to the level to a functional level, I would say. And I think they're behind. I think whatever PlatformIO / Visual Studio Code is doing here is bang on. It's right. And define should be a certain color. Variable should be a color. Variable should be different than the value you set them to. Whenever you do month plus plus, like a variable incrementer, the plus plus should be different. All these things just make coding so much more pleasant and faster. And again, can you code without them? Sure, but it feels like such a step down. I'm like, I have to work so much harder. I mean, we could go back to like starting a car with one of them, get in front of the car. It kind of feels like that just a little bit. So it's not a knock on Arduino per se, but it's just like if you're trying to make things easier for a beginner, wouldn't you want to make things easier? I mean, what's wrong with having those colors? Something to think about. Okay, I would like to see what code June is running here. So the way to do that in Arduino, you double click on it, Control C, Control F, Control V, and you start looking. And of course you can jump right to it. I don't have any other functions named June, so that's good. That's easy to find. And there it is. Of course, now it turns out I'm running another function, sine wave B. Well, what's that? Control C, Control F, Control V. That's not a big problem either. I don't mind using Control F. Oh, wait a minute. November? No. Okay, good. That wasn't so bad. I was worried I was going to have to scroll through 15 of these things because I may have used sine wave B a billion times. And so that's kind of cool. I'm happy with that. But what about analog write? Now this is more advanced. If I wanted to see analog write, there is no way to get to the code for that from here. Maybe that's good for beginners. I don't know. But sometimes I want to get to it. And more importantly, there's a lot of times where I may need to get to a function within a library. If I have a LED matrix library, I need to know if it's rows or columns or, there's a million reasons. I just need to right click and get to it. It's nice. Well, PlatformIO, we need to get to June. Of course, we learned about the outline. We jump right to it, and there's the code. And sine wave B, then, we just right click and go to definition. Actually, hang on. I did mess up here. Let's go back to loop, because we were calling June. And the whole point of this one is say I can also, if I see the code right here, I don't need the outline. I can just right click and go to definition and see the code instantly without any searching, and there's no chance of getting lost. And what I mean by that is when we searched for sine wave B on Arduino, we had to bounce through a few. A big deal? Not really. But with this, we never bounce through anything. We always go straight to the code every time. So here we are in sine wave B. Now, what I showed you before was the analog write. If we needed to dig in analog write, heaven forbid, God forbid, right click, go to definition, and here it is. And this is the nasty code in the depths of Arduino hell for people who aren't, it might look scary to somebody who's not used to real C and C++. But for me, this was a small feature, but I use it 20 times a second, 20 hertz. I use this 20 hertz, I will say. And I just find it nice not having to search through things. I mean, is it necessary? No, that applies to all this stuff. I just showed you how to get to a function definition quickly. The definition is the code, the defining of the code. Well, sometimes you need to get to the declaration of the function quickly, and they're usually in different spots. Very often, especially C and C++, like Arduino uses. So I use the TM1640 library for my LEDs, and I've got hundreds of LEDs on my front, for my synth panel, sorry. And I've got hundreds of LEDs on that synth panel. And so they were too bright. I was like, well, how do I knock the brightness down? I checked the documentation, didn't really see anything, and that happens with Arduino libraries. Sometimes documentation is so-so. So anyway, I'm in the main .cpp, so I'm in the main file for my synthesizer here, and I know that I called the TM1640 library from my own library. Yeah, it's getting kind of messy. So let's just go ahead and get into my library, and that's easy. I just find anything. So anything with foo-foo in it. Why foo-foo? Why not? So I go to the definition, and just to get the file open. And so now I have the .cpp file open that I need. Now, I know in this case that I did the little constructor or whatever thing. I forget the names of this stuff. Don't ask me the names. This guy. It says, hey, I want to declare, or I want to grab this library and create my own little module thing. Does it tell you the names of these things? No. Okay. So what my plan was is I was trying to figure out how this freaking code works, because surely it's got a brightness somewhere. And so if I right click here and say, go to declaration, that'll get to the .h file, which is what I want. The .h file usually tells you what you can expect to throw into a library or a class. And so I was looking, and then I saw intensity. And so with intensity equals 7, that means the default intensity is a brightness of 7, which is saying this thing only goes to 7. So the default is brightness all the way up. And so what I was able to do was go back into my library, and all I have to do now is just put, well, actually I have it right now, it's a 2. I just added this extra number on the end of the function to override that default function. So I hope that made sense, but this is an example where really quickly you can just right click and get to the thing you need. So there's times when you need to get to declaration, and there's times you need to get to the definition. Both are very different, but both have their uses. Okay, I love autocomplete. I use it a billion times a day. Let me show you why and how. Okay, we need to get to the loop first. That's where I want this code to be. And we got an outline right there, Mr. Loop. Thank you. Okay, so we'll create a new if statement, if current. Oh, well, hey, that was nice. All I typed was C. Current time, that's what I wanted, is greater than, I know it's the 8 incrementer thing. Let's just type in incrementer. This is the one I want. But how do I know that? Well, I kind of already know it, but I also know it because I can mouse over, expands to 8. Perfect. Thank you very much, PlatformIO / Visual Studio Code. So let's go to Arduino land. Arduino. Hey, wait. You guys weren't supposed to see that. Don't look. Don't look. Okay, we're way away from our loop. We need to get to our loop. Where is our loop? We don't have an outline, but we do have Control F, which Control F's really good too. Although, if we had 15 things named loop, that would be annoying. Regardless, same thing. We go here, if current, did I capitalize that T? Probably. Well, luckily I can see it right here. So, good. I'll just steal that one. Is greater than. Okay, before I could only think of increment. I knew it had an 8 in it. But increment doesn't help us. We don't get anything, so that's wrong. So we need to kill that. So, of course, our defines are at the top of the page. So now we have to memorize the code, or the code number, the line number, 194. So we'll scroll to the top, and here it is, increment 8. Good. All right, now what's the square root of 12? More than 3, less than 4, something, 3.2 or something maybe. All right, what's the line code? 194. Got it. I never do that. Now, why did I just do that? Well, I did that because when you're coding, if you're doing anything interesting, then your brain's already maxed out, or at least you're using a lot of it. And that extra 3, 2, or that line number is just one more damn thing you got to think of. And I don't want to have to deal with that. And I know some of you guys, have hyper brains, and you can't talk to girls, but you can remember lines of code. Fine, I can't. So I'm going to go back down to 194. More power to you if you can do this. But for me, I am thrilled that I don't have to worry about remembering lines of code too often. So I'm a big fan of autocomplete. Okay, let's talk about outline. Actually, we don't need that. I am looking for a motion interrupt function. Where is it? Well, I don't remember the exact name of the function because I never remember the exact names of functions. I'm way too busy and important. So we'll just type in motion because I know motion's in the name. It's not motion flag. And this is the only option, as far as I know, we have to do this. It's not motion flag, not motion flag, it's not that, not that. Oh, there it is. Okay, not bad. It only took like, I don't know, 10 seconds. And maybe I could have done it in 5 if I would have, been focusing. Not bad. Well, there's another way to do it. And with Visual Studio Code / PlatformIO, I know I had motion in the name, so I'm going to look at the outline. Motion ISR is right there. So it's more like 1, maybe 2 seconds. See, there's this outline thing over here that I really like. In fact, let me make this enormous, just so you can see it. Does that work? Yeah, it's ridiculous, but okay, so this was a goofy LED project where I have different functions for month of July and the month of June and the loop. You can see all these various functions. Sometimes you forget the names of your functions or your constants. PW in blue, well, that happened to be PB9. That's a pin. You get the idea. But by having all your main stuff in an outline over here and out of the way, and see, normally, and I've got this ridiculous so you guys can see it on your phones or whatever, but if I make this small, in real life, it has no downsides. I don't ever miss this area over here. But it's very nice to be able to, whenever I need to, like, where's the setup? Of course, setup's easy. I can always just search for it. But things that have multiple names in a name that's used a lot. I'm using sine wave a billion times. So if I couldn't remember which sine wave it is, well, on this particular program, good God, I've signed 1,000 times. So I'd have to think more. So outline's just a really nice way to navigate. And without it, I'd be screwed. Okay, so we all know and love serial debugging, where you use a little serial statement, serial.print statement. Arduino can do that with no problem. I want Arduino to add a debugger. And let me show you what a debugger is. Well, we've already loaded this up in debugging mode, which is way slower than it should be. That's another story. But what it allows me to do is, after I've compiled, the microcontroller is running. Okay, now the microcontroller is running full speed. It's doing what it always normally does. But let's just say I find some variables that I want to see the value of. And I've already selected some. Over here, I've added button 2A. I just copied and pasted this in there and selected parameter I took from here. Button time 2, blah, blah, blah. I got 4 variables right here. Well, as soon as this, the code runs into this stop sign, it's going to slam on the brakes. Now, right now, the microcontroller is running, but button 2A pushed is always equal to 0 until I push the button. So let's go ahead and push the button, and let's see if it gives us an instantaneous reading of all the values, all the variables. Let's try it. 1, 2, 3, go! Oh, what we got? What we got? Okay. We have a button ID, button 2A ID. We have a selected parameter. We have button time 2, and we have this to bounce thing. And so let's do it again, and I'll push a different button. Let's see if we get something other than 22. Oh, we got 34. Okay, so this is a good example. Real time, we can try different values, like on the button, and push different buttons, and we will get different results. Now, here's what's cool about this. And again, serial debugging, I would have to print all these statements off, and if it's possible they'd be printing at some high speed. I could always set a delay or come up with some kind of averaging, or you can always come up with cute ways to manage your serial prints, and that's okay. Sometimes that's the way to do it. But it's a lot better just to stay in debug mode and say, okay, what else do I need to know about this thing? Let's go to my note on, and let's say, so this is a synthesizer, so when it receives a note, let's say now that I want to view note and velocity. So we go back to debug. We don't need any of these anymore, these variables. So we'll go ahead and add note in here. We'll go ahead and add velocity in there. And then we'll go ahead and give it a breakpoint. Say, stop right here, please. And when we run it, nothing happens yet. But when I use my little MIDI sequencer, right here, and hit play. 1, 2, 3, go. And we got it. We caught it. That note was note 60 with a velocity of 68. Do we believe it? Let's check it out. Right click, look at the note properties, 60 and 68, perfect. Isn't that cool? From this MIDI sequencer, we sent it out the MIDI port into my synth, read the thing, and through the debugger, we spit it back into PlatformIO. Pretty cool. And so we can bounce around the whole code like this. Any variable we can find, as long as it's running now. Now, you know, Arduino has the loop and the setup. We can't get back into the setup because no one can. Once it's ran, setup is over. But we can get to any variable we want. So it's a really cool way to check what's going on and find for bugs. So you expect a value to be 7 and it equals 13, something's up. That's the clue. So it's very powerful and very useful, and I wish Arduino had it. Please add it. And I do want to point out again, it does require special hardware. It costs $3 for this STM32. One of the reasons I love the blue pill. Don't even look up the Atmel Ice. $60. Take that, Atmel. Make that thing cheap somehow. Okay, we've talked about how I want real deal coloring in the code. When I want everything color coded where everything's easy to see and logic jumps out of the screen. That's what I want. I want to think less because everything's feng shuied correctly. I want the ability to jump to function definitions. I want to right click and I want to be able to jump immediately to the function I want to play with. I don't want to have to search for it. Particularly if I have functions that all start with the same name, I may have to search through 30 things. It happens. Not a lot, but it happens. And same thing, I want to be able to jump to function declarations. That has value. PlatformIO, VSCode, those guys got that right. I want an outline. That doesn't strike me as too hard. Is that going to intimidate a beginner? So if there's a function, I can just click on it and immediately jump to it. I want to be able to put it in alphabetical order as well, because if I want to go to loop, then boom, one click, doof. And lastly, I want debugging. Debugging is a big feature for me. Do I use it every day? No. Is Arduino kind of slow, it seems like, just because of the nature of the libraries and how, you know, I hate to say bloated. I don't want to insult the thing. It's definitely not as streamlined as bare metal C, but it still has value. So give me those features and I'll go right back to the Arduino IDE. But until then, I'm on PlatformIO with VSCode. Out. Of course, you know, if you like this video, like, subscribe, all that crap. If you got any comments, people are always trying to pull comments out of people's heads. You see it all the time, and I know YouTube rewards people that get comments. So leave a comment if you hate this, or like it, or just in the middle. Just say something worthless. Out.